Hello. In this video, we want to use the power rule to find each indefinite integral. So we're going to start out with the integral of t cubed dt. Well, here, the only thing we really need to do is we need to look at the integrand, which is t cubed. I need to add 1 to the exponent. Oops. 3 plus 1 is 4. And then I need to divide by that exponent, which is 4. Because the coefficient out here is just 1, and we're good. Except for one more thing, don't forget, please, to have that plus c on there. Excellent. And that's just the integral of a polynomial. Now over here, the integral of the square root of u du. You might freak out a little bit and say, well, we don't have a square root rule yet. Well, we actually do. And here's why. This is the same thing as the integral of u to the half power du. So we're going to take the integrand, which is u to the half power, and add 1 to the exponent. 1/2 plus 1 is 3/2. And then technically what we're doing is we're dividing by 3/2 and then adding a constant. But if you put this in, it's going to be wrong because this isn't actually simplified. What you need to do is, instead of dividing by 3/2, the same thing as dividing by 3/2 is the same as multiplying by 2/3. So really, what I like to think of this as for this rule is take the exponent and multiply out here by the reciprocal of the exponent. The reciprocal of the exponent is 2/3. So this would be 2/3 u to the 3/2 power plus c. Now notice that you really need to have this plus c on every line where you no longer have an integral symbol. Now over here, you didn't have to write this way. Instead of writing that dividing by 4, what's the reciprocal of 4? Well, 4 is 4 over 1. So the reciprocal of 4 over 1 is 1 over 4. So it would give you 1 over 4 t to the 4th power plus c. And honestly, I would personally prefer this. My lab math will show you more along this line right here, but I prefer this one. Either one will work. Okay, so there are those two. Now let's look at these two down here. For the integral of 1 over t squared dt, this is actually the same thing as the integral of t to the negative 2 dt. And to take this integral, we have to add 1 to the exponent. Negative 2 plus 1 is to the negative 1 power. And the reciprocal of negative 1, well, it's negative 1 over 1, and the reciprocal is negative 1 plus c at the end. Now notice that a negative exponent there means that could go to the denominator. Now keep the negative 1 out front in the numerator. Over just t to the 1st power just means you don't write the 1. So it's negative 1 over t plus c. Excellent. Now for this over here, the integral of dx. A lot of people freak out about this because they see this as weird, and it kind of looks weird until you realize what's going on. There's effectively a constant here of 1 for your integrand. But what is 1? Well, what's the variable here? The variable is x, because this is your variable of integration. So you can actually think of this as the integral of x to the 0 power dx. Now if I take this integral, the integral of x to the 0, well, add 1 to the exponent, makes that x to the 1st power, and the reciprocal of 1 is 1, so it's already out here, and then just plus c. So the integral of dx is just x, and then plus your constant. So the integral of any variable is that variable, plus a constant. Alrighty. Well, I believe that's it for this video. I'm going to go ahead and end it here, and I will see you in the next one. Have fun.